solving systems. This is the last day in this unit, so hopefully we're feeling pretty good with this stuff at around this point. Let's see, word problems. So day 7 was doing solving systems of inequalities given just the systems, right? But now we're incorporating word problems. So how am I going to set up this inequality, and then how do I graph it from there? So let's take a look at number 1. For a hiking trip, you are making a mix of X ounces of peanuts and Y ounces of chocolate pieces. You want the mix to have less than 70 grams of fat and weigh less than 8 ounces. Okay, so that tells me right there those are two different things, because it went from less than 70 grams of fat and then weighing less than 8 ounces. So that tells me those aren't going to be in the same equation. These two numbers are going to be in separate equations just from the units. Okay. An ounce of peanuts has 14 grams of fat, and an ounce of chocolate pieces has 7 grams of fat. Okay. Write and graph a system of inequalities that models this situation. Well, first, let's always start with our let statement, right? We're making a mix of X ounces of peanuts. It even tells what X is, but I'm going to stay on the safe side and always do my let statement. So I'm going to let X equal number of ounces of peanuts. Let's do, number of ounces of peanuts. And then let's let Y equal number of ounces of chocolate pieces. Okay. Now, how are we going to set up our inequality? Well, again, like I just said, we know that 70 grams of fat, right? So that is probably going to have to go with the same units, 70 grams of fat, and weigh less than 8 ounces. Okay, so that tells me that 8 ounces is not going to go with 70 grams of fat. But if we keep reading on, an ounce of peanuts has 14 grams of fat. Okay, that's good. Peanuts has 14 grams of fat. And an ounce of chocolate pieces has 7 grams of fat. So look at what I just underlined. I underlined all three things that are going to be in our inequality. Look, the mix is going to have less than 70 grams of fat. An ounce of peanuts has 14 grams of fat, so we know X is an ounce of peanuts. So let's get our inequality going. So we're going to have 14X plus an ounce of chocolate pieces has 7 grams of fat, so plus 7Y. Then the first piece, less than 70. Okay, so it wants to be less than 70. Great, there's our first equation. Now what's our second equation going to be? It's going to want to weigh, you want the mix to have 70 grams of fat and weigh less than 8 ounces. So altogether, we're going to want X and Y to weigh less than 8, right? So if I just wrote X plus Y, it's going to be less than 8, okay? So this is good now. Remember to graph anytime we graph, whether it's inequalities or linear equations, we need to make sure that we get Y by itself every single time. We can't graph until Y is by itself. So what color do I want to use? I'm going to use red for the I'm going to use green for the first one, actually. Let's do some Christmas colors. I'm going to do, this one's going to be green, and then we'll do the second equation red. Okay, so back to green. And again, I'm trying to get Y by itself. So let's take this. So I'm going to have 14X plus 7Y is less than 70. Getting Y by itself, subtract 14X from both sides. That cancels out. I'm left with 7Y. is less than negative 14x plus 70. Divide by 7 on both sides. Cancels out. So y is less than negative 2x plus 10. Now try and think back to what we did before. I wish I had more room here, but you guys can write smaller. Try and think back to what we did on day 7. I still need to use my test point here, okay? So I'm going to do this over here. A test point of 0, 0, where this is x, this is y. So if I substitute in 0 for y, 0 for x, I'm going to get 0. Is 0 less than, well, negative 2 times 0, anything times 0 is 0. So 0, and then I still have 10, plus 10. So is 0 less than 10? Absolutely is. True. That means we're going to shade towards my test point of 0, 0. Let's make my x right here. Okay? I'm going to shade towards that. Now, again, I don't care if you graph this and then shade it first, or if you want to get y by itself first and then graph and then shade. Whatever makes you happy, do it. Whatever you guys, however you remember it, that's fine. I don't care. As long as it's all done, though, you're going to get the right answer either way. So x plus y is less than 8. Okay. Again, I'm getting y by itself, so let's subtract x from both sides. So y is less than negative x plus 8. Test point of 0, 0. Again, x, y. So 0 is 0 less than 0 plus 8. So is 8 greater than 0? Yes. That's true as well. Okay, awesome. So now we can go about graphing our equations. So I'm going to graph this one, and I'm going to graph this one. Doesn't matter which one you do first. Let's just go ahead and do this one because, I don't know, it's the first one I see. So I have a slope of negative 1 over 1. Okay. I'll write this down just for this problem so we know how I'm doing this. A slope of negative 1 over 1. Okay, that's what the negative x is. And the y-intercept of 8. That's where I'm starting. So y-intercept of 8. So starting 8 up, my first point is going to be here. And I'm going down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Let's go up 1 to the left 1. Up 1 to the left 1. Now, if you recall what I said in class when we were doing the coloring activity with the graphs, we don't need to plot every point, okay? This is plenty of points now, and as long as we have our straight edge, we're fine. We don't need to plot all these points. It just kind of wastes time. If you want to, that's awesome. It's fine. But the line now, we can just do a line. Now, is this going to be a solid or a dashed line for red? Well, this sign tells me it's going to be dashed. It's going to be a dashed line. We got to make sure we know what kind of line we're using. Okay. So it's going to be a dashed line through about here. Again, as long as you have a straight edge, you can kind of pinpoint how it's going to look. That's going to look something like that. Guys, we need to get into a good habit now of labeling our lines, okay? Oops. So make sure that when we graph our lines, I'm labeling what this line is. Which line is this? Well, again, I want to use my original equation. It's going to be x plus y is less than 8. I know I made it into this form, but that's only so I could graph it. The actual line is x plus y is less than 8, so make sure that we write that down here somewhere. Just next to it, x plus y is less than 8. Now let's graph this one. Where is it? Y is less than negative 2x plus 10. Okay. So I have a y-intercept of 10. And I'm going down 2 to the right 1. a slope of -2. So I'm going down 2 to the right 1. And like I said before, you don't need to graph or plot all the points. Just a few will be suffice. Now what kind of line is this? This is also going to be dashed. That is also going to be a dashed line. So let's get my line going. Ooh, this is nice. This is perfect. I'm going to use this. Something like that. Right? Okay. Let's do our shading. No, let's not. Let's not do my shading yet, because if you guys caught me, I didn't label this line. I want to label it. Again, it's 14x plus 7y is less than 70. That's this line here. So this is going to be 14x plus 7y is less than 70. Now we can do my shading. So my test point for the green, 0, 0. Was it true? It was. That means I'm going to shade towards my test point. So let's go back with the green, and I'm going to shade. I'm going to use this. I'm going to shade everything going this way. Okay. Now I know in day 7 I just colored everything in. I'm going to start doing this. I don't actually need to color it, but as long as I know where it's being shaded in, this is perfect. Okay, it's not too messy, and I know what these lines represent. It means that I'm shading everything that way. Now, let's go to the red pen. Now, was this test point true? Yes, it was. For this line, so that means I'm going to shade towards 0, 0 as well, using this one. Okay, so I'm doing it from this line now. Everything going this way. And as you can see, it's a little bit easier to see where these lines are intersecting instead of just coloring it straight in, full force. Right. Okay, great. So we have it shaded in. Now, it wants us to write and graph a system of inequalities that models this situation. Think about this. Think about what we're doing here. What does X represent? And what does Y represent? They both represent the number of ounces of peanuts. So think to yourself, would it make sense, this quadrant right here, this is all negative, right? Everything to the left of the Y axis, this vertical line, everything to the left of this is negative. So we can't really have a negative number of peanuts. And also everything down from everything below the x-axis is negative, correct? So everything down here is negative, everything over here is negative. We can't have a negative number of ounces of peanuts or a negative number of ounces of chocolate. So we only want to use the first quadrant in this example. So we're only going to want to use this piece right here, right? Because we can't use this. This is all negative. This is the only thing that's logical. So let me pull out my highlighter. This is the only piece that is logical in this case. Okay. So let's put a little note here. Let's say only use first quadrant. Right? Only use the first quadrant, and then let's draw our big letter S for our solution. And we should be good. Here's my S. That's my solution right there. Okay? Let's go on to number 2. You are fishing in a marina for perch and rockfish. I don't know who does that, but which are both two species of bottom fish. Now, gaming laws in the marina allow you to catch no more than 15 perch and no more than 10 rockfish per day, and no more than 15 total, right? So you can't catch more than 15 perch and or rockfish in one day. Okay, so this piece here, this kind of tells me a lot. No more than 15 total. I love that word total because that tells me it's going to be x plus y is less than, greater than, or equal to whatever my total is. So that's really nice. Let's use my let statement again. Okay. Let statements help us so much. Let x. What do you guys think x is going to equal? What does it want us to know? Well, I'm going to let x equal the number of perch fish. Number of perch. And you guessed it, I'm going to let y equal the number of rockfish. Whatever that is. So x is the number of perch, y is the number of rockfish. Now, gaming laws in the marina allow you to catch no more than 15 perch. No more than 15 perch. Think about that. It's not going to be an equation. It's not being combined with anything. It's not combining perch, marina, bottom fish. It's just saying you can't catch any more than 15 perch. Well, if x represents perch and I can't catch any more than 15 or less, it's going to be less than or equal to 15. You can't catch no more than 10 rockfish per day, so that's going to be, if y represents rockfish, less than or equal to 10. Then again, no more than 15 total. We're only catching perch and rockfish, so we can't catch any more than 15 total. So x plus y is less than or equal to 15. Now, we definitely need practice with graphing these here. X is less than or equal to 15. Y is less than or equal to 10. Think about how we learned how to do this. Okay? How did we learn how to do x is equal to 15 or y is equal to 15 or x is less than or equal to 15? Okay, that's going to be VUX because of the x, which means it's going to be a vertical line at 15 on the x-axis. How about the next piece? Y is less than or equal to 10. That's going to be HOI, which means a horizontal line at y, when it's 10. Then x plus y is less than or equal to 15. Well, we're going to have to solve for y there. So let's do that now. Let's solve for y. So x plus y less than or equal to 15. Subtract x from both sides. So y is less than or equal to negative x plus 15. Sweet. Let's do my test point. Test point of 0, 0. Okay, substituting in 0 for y. Is 0 less than or equal to 0 in for x, so it's just 15? True. Very true. Okay. Let's see. We still have to do test points for x and y as well. Right? We gotta do test points for those as well. Let's put a little line here. Let's do x is less than or equal to 15. Let's do this one over here. My test point. X is less than or equal to 15. Test point of 0, 0. So, is 0 less than or equal to 15? Well, yeah. Yes, it is. And now the last one, y is less than or equal to 10. Hopefully you guys could just see whether this is going to be true or false if we use a test point of 0, 0. But let's write it out. So y is less than or equal to 10. Test point 0, 0. So 0 in for y is 0 less than or equal to 10. Well, yes, all three are true. Let's go about graphing these now. Look at the inequality. Are they going to be solid lines or are they going to be dashed lines? We always need to make sure all three of these are going to be solid. All solid lines. Okay, let's graph these. Let's start with the first one. X is less than or equal to 15. We're going to need a scale. Here's 0, 0, so here's my test point. I'm just going to go up by ones. Why make life difficult, right? So x is less than or equal to 15. So my x-axis is here. So I'm going to count all the way up to 15 on this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, we're going to need a vertical line here for Vux. Again, it's going to be a solid line. Nice solid line here for x is less than or equal to 15. Again, always label. So we know this is x less than or equal to 15. It's very important for me to label too because I can't really switch colors here in this smart notebook. I could do it in class, but I'm on my computer, so it's not going to work. Now, I need to figure out, actually I can do one of two things. I could shade now, I could shade all the way to the left, or I could graph everything else. You know what, let's just shade now. Why not? It's not going to hurt. All right, so I'm going to shade everything towards my test point, which is all the way down here. So I'm shading towards my test point. Okay, shading everything going over. Okay, let's do y is less than or equal to 10. I'm going to want my line. So I'm going to count up 10 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to want a horizontal line at y is 10. Label your line. Make sure you guys are putting arrows on these. Okay? Make sure you're putting arrows on these. This is y is less than or equal to 10. And again, let's shade. It was true, so I'm shading towards my test point of 0, 0. So I'm going this way now. Everything towards the test point. Okay. Great. Now, x plus y is less than or equal to 15, which we found out was y is less than or equal to negative x plus 15. So we're going to need to plot these. So positive 15. Well, this was 10, 11, 12, 13, 14, 15. First point, and I have a slope of negative 1. So I'm going down 1 to the right 1. Okay, I'm not going to plot all of them because I don't need to. As long as I have 3 or 4 points, that is perfect. So it's going to look something like that. Label the line. Okay, I'm going to put an arrow on it too, just to be safe. And this line is x plus y is less than or equal to 15. Now, was my test point true? It was. So I'm going to shade everything towards my test point. That's everything going this way. All right, and hopefully we can see where our solution is. It's where all three are shaded, and this right here, let's pull out the highlighter. This right here is the only spot where all three are shaded in, right? Here is my solution. Let's get our pen out and let's write that big S. This is my solution. Okay? Alright guys, we're almost done. Last one. Number 3. Mike makes $7 an hour working at the grocery store. And he also makes $10 an hour delivering newspapers. Okay. He cannot work more than 20 hours per week. Okay. Different equation. Because look, here we're talking about money, $7, $10, and now we're talking about hours worked. Think about that. So graph two inequalities that Mike can use to determine how many hours he needs to work at each job. How many hours he needs to work at each job. That should tell me my let statement right there. How many hours at each job? If he wants to earn at least $90. Okay, start off with the let statement. Let's let X equal number of hours working at the grocery store. Number of hours working at grocery store. And let's let Y equal number of hours at newspaper. Let's figure out what are my inequalities. So he makes $7 an hour working at the grocery store and $10 an hour delivering newspapers. Okay, so dollar. Where's my third dollar? I need my third. If he wants to earn at least $90. So see if you guys can set that up. So 7 working at the grocery store. So X is the grocery store. 7X plus 10 at the newspaper, which is Y. So plus 10Y. And he wants to earn at least 90, right? So he wants to make at least 90 or more. So we're going to do greater than or equal to 90. But he cannot work more than 20 hours per week. And it doesn't matter. He has 2 different jobs, right? X and Y. Together, he can't work more than 20. So how would we represent that? X plus Y. And he needs to work less than. He cannot work more than 20 hours, right? So less than or equal to 20. Okay. Well, both, we got to get Y by itself. Got to get Y by itself for both. Go ahead and do that. I'm not really going to walk you through it. You should be able to do this now. Okay, so I got Y is greater than or equal to negative 7 over 10x plus 9. Is this going to be solid or dashed? Solid line. And I want my test point of 0, 0. So, substituting in 0 for Y and 0 for X. Is 0 greater than or equal to, this is going to be 0 plus 9. Is 0 greater than or equal to 9? No. False. So that means we're not going to shade towards the test point. We're going to shade away from it. Okay. Now let's use green for X plus Y. It's less than or equal to 20. Getting Y by itself. So that way I can graph it. So Y is less than or equal to X plus 20. This is also going to be a solid line from this. And a test point of 0, 0. So is 0 less than or equal to 20? Yep. True. Very true. Okay, let's graph this. Let's do the green one first. X plus 20 is less than or equal to, or x plus y is less than or equal to 20. So y is less than or equal to negative x plus 20. So my y-intercept is 20. That's going to be all the way up here. If you go up by 1s on the y and on the x. Okay, and my slope is negative 1 over 1. So down 1 to the right 1. Again, I'm not going to plot all of them, but as long as we have that straight edge, do a nice straight line all the way through. Should look, let's make it right there. Okay, again, label your line, which is x plus y is less than or equal to 20. That's this line. My test point of 0, 0. Again, I don't go in any specific order. You can graph both and then shade. You can graph one, shade one, graph another, shade another. It doesn't matter. I'm going to shade now just because I have the green pen out. So it's shading everything towards my test point. All the way down here. Okay, now let's graph this line. Y is greater than or equal to negative 7 over 10x plus 9. Y-intercept of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going down 7 to the right 10. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I go down 7? Nope, I can't. Can I go up 7 to the left 10 over here? I cannot. So these are the only 2 points I can graph, and then I can do my nice line. About there. Okay, label my line, which was what? It was 7x plus 10y. Oops. 7x plus 10y is greater than or equal to 90. And then I'm going to shade. Was it true or false? It was false. I'm not shading toward my test point anymore. Okay? I'm shading away from it since it's false. It's not always shading towards the test point. Remember to look at where or whether it was true or false. That tells you where you're going to shade. So I'm shading away from the test point now. Everything up. Okay, hopefully we can see where is my solution. Well, my solution is everything in between the 2 lines here. Big S. Okay, and that's the end of day 8.